Pamela. Welcome to my channel. Today I'm gonna talk about there are three types of level method based on the electrical characteristics of the process liquid, and they are conductive or resistive, capacity, and admittance. The conductive or resistive sensor consists of one or more electrodes and an electrical or electronic relay energized when the liquid wets these electrodes. The liquid must be sufficiently conductive to excite the electronic circuit so that the device can discriminate the separation between the liquid and its vapor. For example, in a steam boiler, the instrument is used as high and low level alarm or control, uses electric relays for liquids with good conductivity and electronic relays for liquids with low conductivity. The minimum impedance is 20 megaohms per centimeter, and the supply voltage is alternating to avoid oxidation phenomena on the probes caused by electrolysis. When the liquid wets the electrodes, an electric circuit is closed, providing the electronic relay with a delay timer that prevents its interlocking in the event of a wave of the liquid level or momentary disturbance, or instead, two slightly separated electrodes are arranged electrically interlocked in the circuit. A variant of this instrument is used to control the level of melting glass. In this, an electromechanical system lowers the electrode until it touches the molten glass surface that is conductive at melting temperature. At the moment of contact, the electrode is vertical, and its position is marked on a recorder. Moments later, it reverses its movement until the electrical contact is broken, and the cycle repeats itself. Conductive level methods are versatile, without moving parts, and their measuring range is large. However, the length of the electrodes is a physical limitation. The liquid must have a minimum conductivity, and if its nature requires it, the current must be low to avoid deterioration. The sensitivity of the device should also be adjustable in the presence of foam. The capacitance level sensor measures the capacity of the capacitor formed by the electrode immersed in the liquid and the walls of the tank. The capacity is linearly dependent on the liquid level. In non-conductive fluids, normal electrodes are used, and the total system capacity is made up of the liquid capacity, the upper glass capacity, and the upper connections. In conductive fluids with a minimum conductivity of 100 microohms, the electrode is usually insulated with Teflon, with the additional capacities between the insulating material and the electrode intervening in the liquid and gas zone. The electronic circuit feeds the electrode at a high frequency, which reduces the capacity reactance of the assembly. The electronic circuit feeds the electrode at high frequency. The electronic circuit feeds the electrode at a high frequency, which reduces the capacity reactance of the assembly and makes it possible to partially alleviate the inconvenience of the possible coating of the electrode by the product. The system is simple and suitable for many kinds of liquid. However, in conductive liquids, conductive solids or liquids that are in suspension or emulsion and exist in air or vapor bubbles decrease and increase the dielectric constant of the fluid, which leads to an error. Furthermore, by lowering the level, the insulating portion of the electrode can become covered with a liquid, and the additional capacity this represents also leads to considerable error. The accuracy of the capacitance transducers is plus minus 0.1%. Their advantages are that they have no moving parts, are light, have good resistance to corrosion, and are easy to clean. They have practically unlimited measuring range and can be used to measure the level of interfaces. Its disadvantages are that the temperature can affect the dielectric constants with a 0.1% increase per centigrade, and that the contaminants that the liquid can bring can adhere to the electrode, varying its capacity and falsifying the measurement in the case of conductive liquids. Disadvantage that is solved by operating the system at high frequency or incorporating a phase detector. Radio frequency capacitance or admittance level sensors use radio frequency pulse modulation techniques whereby the transmitter converts the signal from the vertical electrode immersed in the tank into an output signal in the form of a variable period digital pulse. A microprocessor provides the 4 to 20 mA DC output signal, and the optional HART protocol allows remote diagnosis, change of measurement range, calibration, etc. thanks to the digital signal. There can be two cases. One, that the liquid is not conductive, so the electrode must be, and two, that the liquid is conductive, so the sensitive electrode must be covered with an insulating material such as Teflon. In non-continuous level detection, a relay trips when the material rises above or falls below a specified point, or when an interface occurs at a certain point in the tank. However, a conductive coating of the liquid on the sensor can cause false trips of the relay when the material has risen or fallen from the detection point. The formula for the capacitance of the electrode tank assembly is the first one on the screen. As the system uses a radio frequency signal, impedance must also be considered, which is the position for the flow of current and which is calculated with a second formula. The instrument circuit measures the components of resistance and capacitance due to the possible electrode coating, and solves the equation relating resistance and capacitance to result in a 4 to 20 mA DC signal or digital that is independent of possible coatings on the electrode. In order for the electrode to ignore the effect of the conductive coating, a second element is added to the electrode, called the excitation shield, fed at the same voltage and frequency as the measuring element. In this way, as there are no potential difference between the excitation shield and the measurement section, current cannot flow through the coating towards the tank walls, thus eliminating erroneous signals due to the current circulation through the conductive coating that surrounds the probe. In this image, we can see the coating error. The submerged portion of the electrode generates a pure capacitance. There are virtually no conductive components, since the electrode is insulated. However, because the upper section of the electrode is coated with conductive material, it generates an error signal consisting of a resistive conductance and pure capacitive susceptance component out of phase at 45 degrees. The coating error can be eliminated in two ways. In method A, the capacitive component is subtracted from the total output signal, thus canceling the error signal. Method B introduces a 45-degree phase shift to the full measurement, which cancels the signal part of the error. These types of instruments depend on the dielectric constant of the material rather than its conductivity. That is why they can be used in the spot and continuous level detection of conductive and non-conductive materials and in the detection of interface of immiscible liquids. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós! Oh no, oh no, 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 no. The minimum